Sketch the graph of the curve y equal to x minus 3 into x minus 7 divided by x square. To plot the graph of this given curve, first we have to select the domain, that is the x value for which the range or y value is 0. So the y value y equal to 0 for this in this equation for x equal to 3 and 7. So the domain of this graph is 3 7. Then we will find out the critical point. For critical point we have to take the derivative and solve for the derivative of the function, that is the first derivative of the function to be 0 to find out the critical point. So the given function is y equal to x square minus 7x minus 3x plus 21 divided by x square. I have multiplied the two functions x minus 3 and x minus 7. So x into x square, x into 7 7x, then 3 with x 3x plus 7 into 3, that is equal to 21. So x square minus 7x minus 3x plus 21 divided by x square. So that will be equal to x square minus 7x minus 3x. So minus 10x plus 21 divided by x square. So x square divided by x square, it is equal to 1 minus 10x divided by x square, that is equal to minus 10 by x, and plus 21 divided by x square. And to find the critical point we have to take the first derivative is equal to 0. So dy by dx, we have to find out the derivative of this function. So derivative of y with respect to x, for this term the derivative is equal to 0. For the second term the derivative will be equal to 10 divided by x square, and for the third term it will be equal to minus 42 divided by x cube. And we have to take the first derivative is equal to 0 to find the critical point. So if you solve this, in the denominator you have x cube, so in the numerator you have 10x minus 42, that is equal to 0. So 10x minus 42 is equal to 0, or 10x is equal to 42. So x is equal to 42 divided by 10, so it is equal to 4.2. So the critical point, the x coordinate of the critical point is 4.2, and if you substitute the value of x coordinate here, you can find out the y coordinate. So I have calculated here the y coordinate. You see, for x equal to 4.2, the y coordinate will be equal to y equal to 1 minus 10 divided by 4.2 plus 21 divided by 4.2 square. So this will be equal to 1 minus 4.2, that will be equal to 42, and 10 go to the numerator, so 100 divided by 42 plus 21 divided by 17.64, 4.2 square, that is equal to 17.64. So this will be equal to 1 minus 2.4 plus 1.2. So this will be equal to minus 0.2. So the curve have a minima at 4.2 and minus 0.2. Why there is a minima? Because if the first derivative is greater than 0, here the first derivative is greater than 0, then the curve is increasing, that means the curve have a minima. So the curve have a minima at the point 4.2 and minus 0.2. Then we will check whether the curve is concave upward or convex upward. And to know whether the curve is concave upward, we have to, or convex upward, we have to take the second derivative. And if the second derivative greater than 0, then the curve is concave upward, and if the second derivative is less than 0, then the curve is concave downward or convex upward. So the first derivative is given by dy by dx is equal to 10 divided by x square minus 42 divided by x cube. So the second derivative will be equal to minus 20 divided by x cube plus 126 divided by x4, and we have to take at the critical point the second derivative is equal to 0. So if you take the subtraction of these two terms, in the denominator you have x to the power 4, so this will be minus 20x plus 126 is equal to 0. So minus 20x plus 126 is equal to 0. So minus 20x is equal to minus 126. So x value is equal to 126 divided by 20. So it is equal to 6.3. So you see, the second derivative is greater than 0. That is why the curve is concave upward. Then we will check the asymptotes. For vertical asymptote, the denominator, we will take the denominator to 0. So if you take the function, we have found out that the function y equal to x minus 3 into x minus 7 divided by x cube, and after solving we have got it 1 minus 10 by x plus 21 by x cube. And for vertical asymptotes, we have to take the denominator is equal to 0. So if the denominator is equal to 0, that means limit of this function y taking x approaches to 0, so this value will be equal to infinite, this value will be also equal to infinite, so the function will be equal to infinite. So for vertical asymptotes, when x approaches to 0, the y value will be equal to infinite. And for the horizontal asymptotes, we have to find out the limit at infinity. And if you find out the limit of the given function y taking x approaches to infinite, the function is 1 minus 10 by x plus 21 by x square. When x approaches to infinite, this value will be equal to 0, and this term will also equal to 0, so the limit will be equal to 1. So when x value approaches to infinite, the function will be equal to 1. This is the horizontal asymptote, and this is your vertical asymptote, that is when x approaches to 0, the y value approaches to infinite. Now you can easily plot the graph. This is your x-axis and this is your y-axis, and we have found out that the domain of the given function for which the range is 0 is 3 and 7. So the function domain of the function, or the x value of the function, lies between 3 and 7. And the second thing is, we have a minima at 4.2 and minus 0.2. So here you have a point, x value is 4.2 and y value is equal to minus 0.2. So here the function have a minima. And from the second derivative condition, we know that since the second derivative is greater than 0, the curve is concave upward. So this will be the nature of the curve, that is concave upward. And from the asymptotes, we have found out that when x approaches to 0, the y approaches to infinite. And you see, when x approaches to 0, the y value approaches to infinite. And when x approaches to infinite, you see, when x approaches to infinite, then y will be equal to 1. This is the line, asymptote, horizontal line, and this is your vertical line. This is one asymptote, vertical asymptote, and this is your horizontal asymptote. And here when x approaches to 0, you see the asymptote, from the asymptote you see the y value approaches to infinite, and this is your x asymptote, or a horizontal asymptote. and when x approaches to infinite, you see the y value approaches to 1. So this will be the nature of the graph, a sketching of graph of the given function y equal to x minus 3 into x minus 7 divided by x square. Thank you.